In this session, we're going to take a look at delimited log file monitoring in EventSentry. And with delimited log files, we mean structured log files that follow a specific pattern or structure, such as DHCP logs, IIS logs, and so forth. So I have the management console open here, and I'm going to explain how we create a structure, a definition for a structured log, so we can mirror the type, the contents of that file in EventSentry. In the previous video, we just looked at non-delimited log files, and that setup is a little bit more simple because all we really have to do is define the file in EventSentry. So if we go to log files here in the management console, we'll see that we have defined files and file types here. Same thing up here on the ribbon. And we can see all the files that are defined here. So EventSentry ships with a few definitions, for example, IIS, DHCP, and so forth. So the first step in monitoring a file, as explained in the previous video, is always to create or to set up the actual file so that EventSentry knows where this file is. So you can see here that we have descriptive names that the user defines. So for example, DHCP Windows, and a path to the file. And finally, the type of file it is. So we can see here that we have files that have a specific type set, for example, DHCP, and then we have others that are set to non-delimited, for example, the setup API log and the HMail server log. What we are going to try to do now is monitor a DNS log file. So on Windows domain controllers, you can configure the DNS server to log all activity to a log file. And we're going to import and monitor this file in real time with EventSentry, but also mirror that file so we can search for specific columns. So I'm going to show right here what the purpose and what ultimately the goal of this exercise is. So in the web reports, if we go to features and delimited log files, then we get to this page here. In this particular case, we only have one log file defined. So you can see up here, it just says DNS debug here. So here we can see that the file has been structured and split up into different field types. For example, protocol. So the majority of data seems to be coming from the UDP protocol, but then we have send and receive fairly evenly split. And the nice thing about that is that we can now actually filter on certain things. So for example, we can say, okay, let's restrict this to the last, let's say 30 minutes. And then we can say, well, we only want to see send activity. So now we've filtered this down to just send. And now we can take a look at the log file and only look at send data. But let's take a look at what the file actually looks like. So this is the actual raw log file as logged by the Windows DNS server. And you can see here that we have different fields, mostly separated with a space character. And here we also have a definition and description of the log file. So it starts off with the date and time, of course, so date and time. Then we have a thread ID. Then we have a context that seems to always be packet. Then we have a internal packet identifier. So this is just some unique number or looks almost like a MAC address. Then we have the protocol, so UDP versus TCP. We already saw almost everything is in UDP. Then we have the send receive indicator. And finally, we also have the remote IP address. We have an XID and various more data up until to the very end where we have a question type, a question name, and so forth. So we don't want to really use a non-delimited log file method for this because it would basically log everything here in one line, and we wouldn't be able to filter or group things by things like the protocol or send receive or even the IP address, which is why we're mapping this file into EventSentry by creating a definition. Now, I've already gone ahead and done most of the work, and I created this definition. And again, the definitions are right below the files, and we already have a number of definitions that ship with EventSentry, such as IIS 8510, Radius, SMTP protocol logs for Exchange server, and DHCP for Windows, and the Windows DHCP server. So DNS debug has already been defined here. I'm going to double click that. And now let's take a look at this dialog. It's a little overwhelming, but once you understand how it works, it's not that difficult. So just like with everything, we start off with giving this definition a name so we can refer to it. The next field is the field delimiter. So we already established that the field delimiter is a space character. Sometimes we have semicolons, commas, and so forth. In this case, it's a space. Comments start with, so very often in log files we'll have comments that start with a specific character, such as a semicolon, for example, or the pound character and so forth. Here we have characters we can ignore, that we can remove. So EventSentry will essentially remove these before it's being written to the database. We can skip empty fields, which means that EventSentry will essentially ignore any field that doesn't have any data, not even treated like an actual field name when it comes to the mapping. Merge remaining text means that if we're at the very end of the last field, and I'm going to get into that later, then it will essentially merge all remaining columns, even if they have a separator, into this last field here. And finally, of course, we can define the timestamp. So if we're actually analyzing a date and time field, as we are doing here, then there may be different formats being used. There may be a different date format. It may be the American format. There may be the 24-hour time period and so forth. So here we can help EventSentry out a little bit and essentially say, are the times in UTC or not? And we can also tell EventSentry to prefer the US date format. So if you're in Europe, you probably do not want to check that box. But now that we have all these general settings out of the way, how do we actually map this file into EventSentry? So we're going to basically start just by determining which columns this file has and which columns we want to save, we want to actually store in the database, and what type of data they are. So in this case, it's fairly simple because we have the date and time as the first two fields. So technically, they would be considered 2 or even 3 different fields because there's a space character in between there. But EventSentry is smart enough to parse this date format automatically and treat it as a single field. So that's what I've done here. So it just gave it a descriptive name. Again, you can call this anything. And I basically assigned a file type. And this is where it gets interesting. So when we map a log file to EventSentry at the limited structured log, then we have to assign file types, unique file types, to each column. And there's a variety of fields that are being offered, field types. So there's 18 different types of integers, various text fields, and lookup text field. And I'm going to explain those as we go along. You can only assign each type once. So now that I've already assigned number 37, date and time, I cannot assign this 37 to another column in this file if I wanted to. Our log file here only has one section, only one column with date and time. But if there was another one with date and time, we would not be able to use 37 again. We would have to use 38. Which also means if there were 3 date and time fields, which of course is somewhat unlikely, we wouldn't be able to map this file into EventSentry, or at least not parse it as date and time. So that's the first. The next column is the thread ID. So what I've done here is I defined this field in the definition, but I set it to ignore. Because what I'm basically saying is I don't really care to store the thread ID in the database. Just ignore that field. The next field is the internal, is context, number 4. So the context seems to always be packet. So there's 2 things we could do here. If we know in advance that for some reason packet is always logged, then we could also ignore this field and simply set it to ignore. I, however, set this to a lookup text. And what does that mean? So lookup text really means is something that you want to use if the value in this column repeats itself a lot. And in this particular case, of course, it repeats itself a lot because it's always packet. But if we imagine that there were 3 or 4 different types of context indicators, then that would still make sense. And the advantage is that EventSentry actually just stores a pointer to this lookup value in the actual data rows in the table, in the database. So instead of storing packet over and over and over again, it essentially just assigns an internal ID to this packet text and references that ID. So that can really help conserve database space when you're collecting or storing millions of rows of data, especially when that text field is very long In this case, it's not that long. However, for the sake of this example, I've set this to a lookup field. And again, we can see here it's number 29 that does not repeat itself. If we were to say we want to store this as is, we do not want to write this to a lookup table and just store it and keep repeatedly store a packet in every row, then we would have to set this to a regular text field and not a lookup text field. So now let's move on to the next field. So now we have the internal packet identifier, but notice that there's also a space here in between, which can potentially confuse EventSentry a little bit because it considers it a field type that's empty, because this is a separator, so there are two separators here. So which is why I've set this to nothing and set it to ignore. So that's important. If you have, space delimited log files are not my favorite. They're generally hard to read, and I'm honestly not sure why people still use those. So delimited log files that use things like type character or a comma or a semicolon, generally much easier to decipher. In any case, the next type we have is the internal packet identifier. This value is not a good candidate, is likely not a good candidate for a lookup field unless we can determine that it repeats itself a lot. So hard to say in this case. It does look like it repeats itself quite a few times. So this may also be a good candidate for a lookup text. But in this case, I decided that we don't really care to store this value, so it's set to ignore as well. The next field is UDP. That is a classic case for a lookup value because essentially this field can only have two types of values. Either it's UDP or TCP. Now it is very short, so for that purpose, it wouldn't be a big deal to simply store this type of text, repeatedly store the same text in the table. But since the minimum length is 512 characters, it makes more sense to make this a lookup text field. And the same thing goes to the send receive indicator. That only has two values, either send or receive. So for that reason, again, it's set to a lookup text field, and notice how this is now 30 and 31 because we cannot repeat and reassign the same type over and over. After send and receive, we have the remote IP address, and that in most cases is a great candidate for a lookup field because it does repeat itself frequently. So as you can see here, the remote IP again is a lookup text. Then we have the XID field, which is being set to ignore in EventSentry because we don't need that. And finally, we have the query response. Now, this what we're doing here is we're essentially merging all of these remaining text fields into a single text field because we're not mapping these individual columns into EventSentry anymore. We could, but for the sake of simplicity, we just decided to store everything that follows the XID into a single field. And that's why up there we have the merge remaining text checkbox set, because it essentially says that everything after the XID column, which would be here, is to be merged into a single field. And that's what we did. So we gave it a name, data, and we assigned it to the text column. There's different text columns that we have available. Fewer characters, more characters, and even more characters. Since we can see that in general, this isn't much longer than maybe 100 characters or so, we use the 512 character max field type. So now that we've set this up, we can see that it's been assigned to the DNS log here as a type. So it's not set to non-delimited, but we have this configured here. And once EventSentry starts monitoring this file, we can review the contents in there, but also sort and filter based on the file type. So going back to the summary, this is super useful. So if we wanted to say, oh, let's see all TCP data, then we can do that. Let's see if we have something in the last hour. Nope, there's nothing. So last 12 hours. Last 24 hours. We have one TCP entry here. So if we click that and filter it out, then we can take a look at it and we'll see the contents of this one packet that was sent via TCP. Now we got to remember that just setting up a file in a file type, a log file definition, aren't really enough. We also need a package. So if we look at the log file packages here, we have a DNS package, and that package is created just like we create any other package with the same rules as in automatically assigning, manually assigning, setting it global, and so forth. So this package is assigned to just the domain controllers. We could just as well go here and go to properties, make this a global package, and automatically assign it to a domain controller and make this a global package. It's actually recommending that. So now I don't have to ever worry about assigning this package again. It's automatically always going to be assigned to a domain controller. So even if I spin up additional domain controllers. And in there, I have a DNS object, and that's where I'm telling EventSentry, so where is this data going? So I have the primary database set up here. We're including all lines. We're not excluding anything. So anything that happens in this log file is going to get written to the primary database. This thing is agnostic to what type of log file this is, so it doesn't really care. Is this a delimited or a non-delimited log file? So just like we did with the HTML server in the previous session, where we basically set up some event log alerts, we can do the same thing here for the DNS log. So if there's a particular text in that log that we want to intercept, maybe it's an error, maybe it's something specific domain or something we want to search for and get a real-time alert on, then we can do that. And it works the same exact way as it would with a non-delimited log file. So you're welcome to review the other video for more details on that. So to summarize, we go to log files, we define the files and types. First, you want to set up the actual log file definition. In this particular case, it's called the DNS debug log, but we can look at other ones too. For example, DHCP, you can see here it has a different delimiters, a comma, and a lot of lookup text values, mapping, again, the timestamp, description, IP address, hostname, MAC address, and so forth into EventSentry. Once we have the definition, we can create a log file and assign that definition. So we have a DNS log file with the DNS debug definition. And once we've done that, then we can create the package and add the DNS log, for example, to that package by clicking the add button. We can't choose DNS here anymore because it's already been added. And since creating that mapping of the log file is potentially the most confusing and complicated part of it, I created another diagram here that outlines and visualizes this a little bit better. So you can see on the top the log file definition that we already set up and looked at earlier, and in the middle we can see the actual log file. All the areas in red are essentially fields that we're not looking at, that we're ignoring, and then the green arrows point obviously from the actual column types in the definition down to the actual log file. And we can see that on the very right here, we're merging the rest of the log file into a single last field, the data field. And on the very, very bottom, you can see what it actually looks like in EventSentry once we've extracted the fields that we're interested in.